Okay guys, so today we're going to go over section 5.2 from your book, medians and altitudes of a triangle. I'm going to do two separate videos. This one's just going to be on medians. I'll do the altitudes next. Okay, and then you'll have a worksheet to work on tomorrow in class. So what is a median? A median is just a segment that we draw from the vertex of a triangle to the midpoint of the opposite side of the triangle. So in this picture here, I chose this vertex and I drew a segment from here to the midpoint. If this is the midpoint, remember that on this side, it cuts the side in half. So this piece of the side will be congruent or equal to that piece of the side. Okay? And every triangle has three medians, so I could draw another median from this vertex to the midpoint, this opposite side. And notice I've got different tick marks because I don't know what the lengths of the sides of this triangle is, so they're not necessarily all the same. Okay, and then I can draw another median here, and that would make this piece congruent to this piece. Okay, and you notice if we draw all three medians, they all intersect at a point of concurrency. Okay, so we call that the point of concurrency. And for the medians, the point of concurrency has a special name. It's called the centroid. So the center here, or this point of concurrency, is called the centroid of the triangle. And if you had a triangle of equal density, if you cut it out and put it on the tip of your pen, you could balance it perfectly. So it's also called the center of gravity. Okay, so the centroid is the center of gravity of a triangle. All right, so let me just write that down because I think I forgot. Centroid equals the center of gravity, meaning you can balance it. If you put your pen tip on that point of a triangle, you can balance it on the tip of your pen. Okay, so in any triangle we can draw three medians. Those three medians intersect at a point of concurrency called the centroid. Okay, the median is just a segment from a vertex to the side opposite at the midpoint. Okay, so from the vertex to the midpoint of the side opposite, and if this is the midpoint of this side, CB, then those two pieces are congruent. And if this is the midpoint of AB, then these two pieces of the side are congruent. And if this is the midpoint of side AC, then those two pieces of that side are congruent. And the important part about this is application. So the distance from any vertex to the centroid, so from here to here, this is P, by the way, I know it's kind of sloppy, but this is a P. The distance from any vertex to a centroid, so this distance here, or this distance here, again from the vertex to the centroid, or this distance here from the vertex to the centroid, is 2/3 of the whole segment. So this piece here is 2/3 of, so AP is 2/3 of AE, and BP is 2/3 of BF, of the whole thing, and CP, this is 2/3 of CD, the whole thing. Okay, so remember that 2/3, so that means that which I have written over here, that means that this little piece here, PD, is 1/3, right? Because 2/3 plus 1/3 equals 3/3, or the whole line. So this is 1/3 of the whole line, and PE, this one here, is 1/3 of this whole segment, and PF, this little piece here, is 1/3 of that whole thing. So these are the two formulas you need to know in order to solve problems concerning the centroid. For example, this is I think example 1 from your book. And by the way, this starts on page 333 in your book. Okay, so it says in triangle ABC, so they're giving you a picture. Q is the centroid and BE is 9. So I know that this whole thing, B to E, is 9. Okay, they want you to find BQ, they want you to find this piece here, and they want you to find this little piece here. Okay, so what do I know? I know that this piece here from the vertex to the centroid is 2/3 the whole line. So I'm using this formula right here. Okay? And I'm looking for BQ. Well, I know that BE is 9 because they told me it was. So if I plug in a 9 for BE, I have 2/3 times 9, and I rewrote it as little fractions in case. I know a lot of you don't like fractions. So 2/3 times 9, remember when you multiply fractions, you multiply straight across the top, you multiply straight across the bottom, you get 18 over 3, and then of course you would want to reduce that, so it's 6. So I know that BQ is 6. And, you know, I can do one of two things. I can solve it, or I can just say, if this whole thing's 9 and this piece is 6, then 9 minus 6 makes this 3, right? But technically speaking, you could say that this little piece here, QE, is 1/3 of the whole line. Well, that's 1/3 times 9 because the whole segment is 9, and 1/3 times 9 is 9 over 3, or just 3. Here's another example. This is example 2 in your book. In triangle JKL, PT is 2. So what I know, I redrew the picture. I know that this little piece of the segment here is 2. They want us to find, let me just use a different color. They want us to find KP, the purple segment here. Okay. Well, what do I know? So I made a little bit of a mess of this. So I know that this little piece here is 1/3 of the whole piece, so I can use that formula. I also know that this piece, KP, is equal to 2/3 times KT, right? So I can use either one. Well, I'm going to use this one. Why? Because I know what PT is. It's 2, so if I plug a 2 in for PT, I know that that's 1/3 of the whole line. And if I multiply both sides by 3, I get 6 is equal to KT. So what I know is that the whole segment from K to T is 6. And if I take the whole line and subtract what was given, which was 2, that tells me that KP is 4. That's it. Okay, so you're going to do some practice problems on this on a worksheet tomorrow in class.